In my first video in this series of rectangular fittings that I'm going to do, I started off doing a rectangular 90-degree elbow. And during that video, not only did we start off with the very basics as far as the layout is concerned, but we also looked at the formulas that were related to the cut sizes. And in that video, I had talked about what happens when it is not a 90 as far as our cut sizes are concerned. And the example that I used there very quickly was a 75-degree elbow. And what I'd like to do is take an elbow that is of a different angle than a standard angle, not 30, not 45, but something that's a little different. So not only can we see the different cut sizes, but we can also determine approximately what we're going to need for material as far as our cheek size is concerned. So that's what we're going to have a look at now. So to get started here, what I'm going to do is I'm going to start off with our duct dimension of 6-inch, and we're going to put on a 5-inch throat radius. So we're going to add that on here as well for our 5-inch. So as I mentioned, instead of doing a normal standard angled elbow like a 45 or a 30 or a 60, I'm going to pick something a little different so I can demonstrate how we can actually get that 50 degrees without using a protractor. I demonstrated this in one of the other videos, and the method that we're going to use is called the line of chord. And the line of chord, we're going to take the sine of the angle times a distance that we choose, or let's call it a run. So for the example that I'm going to do, I'm going to use the sine of 50 times, I'm going to use the throat radius as a demonstration for this example. So we're going to use 5-inch. So let's see how that turns out. So we're going to take 50 sine, which is 0.766 times 5 gives me 3.8. So if we want that to the closest 16th, let's get rid of the 3. We're left with 0.833 times 16 gives me 13/16. So we're going to use 3 and 13/16. So as a demonstration here, I'm going to draw a line that represents that 3 and 13/16. And then what we're going to do is we're going to take our dividers and set it to that length. And then from our 5-inch, we're going to scribe an arc. And then from here at the end of our 5-inch line, we're going to draw that tangent of that arc. And that is going to give us our 50 degrees. And for a means of checking, if I take my protractor and put it on here, you'll see that in fact we do get our 50-degree angle on here. So then we can scribe in the remainder of our heel and throat. And that gives us our net pattern. So we're going to add our allowances now. So we add our 1/2 inch for our S and drive connection. And we're going to add our 3/16. And we will show our 1/2 inch down here as well. And then we'll turn that into our combination notch. So we can clip this off between a 30 to a 45. Again, remember, it's nothing really cast in stone, just makes it a little bit easier for us to make that connection when we're putting the S and drive cleat together, and we're going to leave this square so that we have a distinct start point as I demonstrated with that 90-degree elbow. So the next thing that we want to do now is determine what the cheek cut size is going to be for this. Now this is different than the 90. When we did the 90-degree elbow, we knew that we had 5-inch and 6-inch, which was 11. Then we had our 3/16, and then we had our 1/2 inch. So that gave us 11 and 11/16 by 11 and 11/16. In this example, I'd be wasting a lot of material if I cut it like that. So what we want to do is we want to determine what this size is going to be right here. So how are we going to do that? Well, again, we're going to go back and use a little bit of trigonometry in order to find that. If this is the angle, the right angle triangle that I'm working off of right here, this dimension is a little obscure to me because it's projected straight down from there. So the one I know for sure is I know this throat radius and I know my duct dimension. So I know the dimension here for the hypotenuse side of my right angle triangle is 11 inches. So using the sine law, I'm going to take the sine of the angle times the hypotenuse side. And that is going to give me the opposite. So here's my 50 degrees. So that is the opposite. So I'm going to take the sine of 50 times 11, because that's the hypotenuse side. I know that's 5, and I know that's 6. And that is going to give me exactly what that opposite side is going to be. Let's do that. We're going to take 50 sine 0.766 times 11 equals 8.43. Or, if we want to know what that is as a fraction, we're going to get rid of the 8, and we're going to go times 16. So that tells me it's 7/16. So it's going to be 8 and 7/16. So let's see how that turned out. If I measure this from here to here, you see that I get 8 and 7/16. So in order to come up with my cheek size, I know that I need to add 1/2 inch here and 1/2 inch here. Now you might say, well, that doesn't look like 1/2 inch because it's sitting on an angle, and you'd be right. But again, remember, we're trying to get an approximation. The math works, no doubt about it. And actually, I can calculate what this distance is going to be if I want to, but in the shop, we wouldn't take the time to do that. If we measure it, you'll notice that I'm at about 3/8 of an inch. So not enough to worry about. I would just add 1/2 inch to that. Remember, we're trying to get an approximation of the cut size. So we're not necessarily worried about being exactly on this point. So the cut size that I am going to use here is 8 and 7/16. So the cheek is going to be 8 and 7/16, and then to that I'm going to add 1/2 inch here, and I'm going to add 1/2 inch here. So it means it's going to be 9 and 7/16 by, so what do I want to do here? Well, I can stick with this dimension across here because it helps me when I'm laying it out, make sure that I find that exact point here and here. But I'd only be interested in the 5-inch, the 6-inch, and the 3/16. I don't care about anything else. It's going to give me that allowance once I start to draw in my elbow. So I know that that's going to be 11 and 3/16. Now I know you say, well, why couldn't we just simply cut that off across here? We could do that, and we can figure out what that's going to be, but the amount of effort it's going to take me to do that is not worth the material that I'm going to waste or lose when I cut that radius in there. So I'm not really worried about it. That's, again, remember that this is just giving me a quick approximation of what that cut size is so I can reduce the amount of material waste. So the next thing that we're going to do now is calculate what we need for our belts. If you remember from our other example, we use the formula 1.57 times the radius times the degrees divided by 90. And that gave me my belt length. So let's plug the information into our formula. We're going to do the heel first. So we're going to take 1.57 times the radius. So I've got 5 and 6. So I know that that's 11 times the degrees of 50 divided by 90. So let's plug that into our formula. So we're going to take 1.57 times 11 times 50 degrees divided by 90. And that gives me 9.59. 9.59, remember that's net. So what I would have to add to that is my 1/2 inch here and my 1/2 inch here. So that means that in order to get my cut size, I'm going to add plus 1 inch to this to get my gross cut length, which is going to be 10.59. So again, if I want to know what that's going to be to the closest 16th, I'm going to take my 0.59 times 16, and that's going to give me 9/16. So I have 10 and 9/16. Now we need to do the depth of our fitting. And like our previous example, it was 6 by 4, so it's got a 4-inch depth. And I know I need to add that 1 inch to either side. So that means my other cut size for this is going to be by 6 inch. So that represents the heel cut size gross. Okay, now let's do the throat. We're going to use the same formula. 1.57 times the radius. Now the radius that we're going to use here is 5 inch times the degrees of 50 divided by 90. And that's going to give me that belt length. So let's do that one. So we're going to take 1.57 times 5 times 50 divided by 90 gives me 4.36. And that's net. So we need to add that 1 inch, 1/2 and 1/2, which will give me 5.36. And if I want to know what that's going to be to the closest 16th, we're going to take 0.36 times 16, and we get 6/16 or 3/8. So it's going to be 5 and 3/8 by, again, we got our depth of 6 inch. And that's going to be for our throat. So the other thing that I wanted to demonstrate here is I showed you a variation to these formulas that we can use. When we look at this formula right here, 1.57, the one thing I showed you was these two remain constant. So if I take 1.57 divided by 90, I will get a factored number that will help me reduce what this formula actually looks like, or simplify this formula. So what we're going to do is we're going to take those two factored numbers. I'm going to take 1.57 divided by 90, and that's going to give me 0.01744. So I can simplify this formula. I can go 0.01744 times the radius times the degrees to get the belt length. So let's do that. We're going to take 0.01744 times the radius, so we're going to go back to our heel here, of 11, times the degrees of 50. So when I plug that into my equation, I get 0.01744 times 11 times 50 gives me 9.59, which is exactly what I had here, 9.59. And again, we would have to add that 1 inch, because remember, that's net. So again, I'm coming up with the same cut size of 10 and 9/16. And again, the depth is not going to change, obviously, of 6 inch for our overall gross cut size. And we can do the same thing here. I can use 0.01744 times the radius. In our example is 5 times 50. And let's see what happens. So we'll use 0.01744 times 5 times 50 gives me 4.36. So again, we know that we would add 1 inch to that, which would give me 5.36. And my other cut size is going to stay at 6 inch. So we would end up with the exact same cut size as we had before, 5 3/8 by 6 inch. The other thing I showed you was in our first video, we also had one other method that we could use in order to determine what that belt length was going to be. We could then calculate what the circumference of our circle is for the heel and what our circumference is for the heel or for the throat of our fitting. And then from that, we could determine what that's going to be as well. When we did that with a 90, we used pi d, and then we divided it by 4 because we knew that 90 represented 1/4 of the full circle. But in this instance here, we can't do that. We can still use our pi d. But now what I need to do is I need to determine how much of that 360 degrees is represented here by our 50 degrees. So in order to do that, what we're going to do is we're going to start off here, first of all, because pi d will give me the circumference. We're going to take our 360 divided by 50, and that will tell me how many times 50 degrees will go into 360. So I'm going to take my 360 divided by 50, and I get 7.2. So that equals 7.2. So that's what we're going to divide our circumference by in order to determine what portion that 50 degrees is of our 360 degree circle. So as we had done with the 90, I took this and divided it by 4 because I knew that that represented 1/4 of our circumference. Now what I'm going to do is I'm going to divide that by that factor of 7.2. So when I take my 3.1416 times the diameter. Now remember, we got to use the diameter. So I have 5 inch and 6 inch, that's 11, but that's the radius. So I need 22 divided by 7.2. And that will tell me what that portion is going to be, or that belt length is going to be. So let's take a look at that. So we're going to take 3.1416 times the diameter of 22 divided by 7.2, which gives me 9.59, which is 9.59, same as we had before. So we got 9.59. We got the same number just by finding this number here, this factor that we used in order to determine how many times 50 goes into 360 degrees. And we can do the same thing over here. We can take our pi d divided by that factored number of 7.2 to get our belt length. So we're going to go 3.1416 times, again, remember it's the diameter. So if I'm doing the throat, that's 5 inch. That's the radius. So we're going to go times 10 divided by 7.2. So let's do that. So we got 3.1416 times 10 divided by 7.2 gives me 4.36, which is exactly what we got here and here. 4.36. So we can use any one of these in order to determine what that belt length is going to be. I wanted to show you those three because depending on what your instructor is showing you, he might be using this method, he might be showing you this method or this method. But I wanted to demonstrate how all three of those work for you so you can choose for yourself which one you want to use and which one you think is the best and the easiest to remember. As I had mentioned before, I admonish you to create for yourself a formula sheet with all of these formulas on here so that you can refer to it in the future. Keep it with you. Have it in your notes so that you can go back and look at it very quickly and say, okay, this is how we get these sizes. And you'll find that it's going to be of benefit for you, not only while you're going through trade school, but also in the future when you're going to go write for your Red Seal exam in sheet metal, because these formulas are going to in some way be represented on that test. I could go ahead and draw out what those belts look like, but I think by now you should have a pretty good idea how to do that based on some of our previous examples. Thanks for watching.